In Algebra 2, section 7.7, we're dealing with now base E and natural logs. So last section was common logs, and now we're dealing with natural logs that are known as Ln. So you take a log base E of n equals x, and you can transfer it to e to the x equals n. So if I want to write this in log form, this would be log e of 23 equals x. Nope. Yes, this is n, and this is x. It's x. So 4 is x, and x is n. So this is log e of x equals 4. And then they'll also want you to put it the other way. They want you to find this natural log, right? But another way of writing this is ln, like I stated. So this could also be ln of n equals x. So I would write this as this is my n, and this is my x. This is my n, and this is my x. So I would write it e to the x equals, no, e to the 1.2528 equals n. And this one would be e to the x equals 25. So ln and log e, they both represent natural log. So in this one, the rules apply, same with log, right? If I'm adding, right, then I'm multiplying. If I'm subtracting, then I'm dividing. But the number in front of it should go an exponent. So this is ln 3 to the 4th plus ln 6, and combined will be ln 3 to the 4th times 6, which is 3 to the 4th is 81 times 6, which would be ln of 486. Okay? Same thing goes with this. This is 2 to the 3, so this would be ln 3 squared times 4 times y, which would be ln 9 times 4, 36y. So go ahead and pause and write this down. This is just the natural logs are is logs base e, so it would make sense that these logs would all follow the same. These would follow the same rules as logs that you've learned. So nothing really new. It's just we're instead of common log or regular logs of different bases, we're doing log of base e. Let's go ahead and pause and write this down. So on number 4, we're dealing with exponential with a base e. Now the opposite of exponent with base e is your natural log. So base e natural logs are cancel each other out. So that becomes useful when we want to separate e from everything else. So what I can do here is this becomes, I'm going to isolate this because there's nothing I can do until I isolate this. So I'm going to go ahead and do minus 4 on both sides. I end up with 3 e to the negative 2x equals 6. Then I'm going to divide by 3. gives me e to the negative 2x equals 2. Then I'm going to natural log both sides. So this cancels out, leaving me with negative 2x, and then whatever ln of 2 is, which is 0.6931. Then I'm going to divide by negative 2. And then I end up with, this canceling out, I end up with x equals 0.6931 divided by negative 2, which is negative 0.3466. So, from here, I'm going to apply the same thing. Remember, if ln is the opposite of e, then e would be the opposite of ln. So I'm going to take this 2, just like log, and put it in front. So I have ln, oh no, instead of doing that and making it more complicated, because I can do that, I'm just going to divide both sides by 2. So it gives me ln to the 5x equals 6 divided by 2, which is 3. And then I'm going to base e both. This cancels out, giving me 5x equals e to the 3rd. Which is 20.0855. Then divide both sides by 5. I end up with x equals 4.0171. So these are just examples of us using ln or e, but all these rules you've dealt with before. All of them are just rules of keeping the equation balanced and doing opposites to get rid of them. The key is to isolate it. Before I do any of the e to the ln, natural log to cancel the e out, or e to cancel the ln out, I need to make sure to isolate it first. Just like when we're dealing with square roots, just like when we're dealing with anything else, everything else should be taken to the other side. And again, 6 is an inequality, but all the rules should stay the same. I'm going to take this 2 and I'm going to bring it to the front, which gives me 2 ln 3x plus 1. It's greater than 8, which then I divide by 2. This cancels out, giving me ln 3x plus 1 is greater than 4. And I'm going to e both sides. This gives me, this cancels out, giving me 3x plus 1 is greater than e to the 4th, which is 54.5982. I'm going to subtract 1 from both sides. 3x is greater than 53.5982. Then I'm going to divide both sides by 3. This cancels out, and I end up with 18.1993. So, same thing with the inequalities. Remember, we are just treat it like an equal sign like this, except if I multiply or divide by an equal sign, by a negative number, that's when I flip the sign. Other than that, they're just equal signs. So, go ahead and pause and write this down and try page 505, numbers 2, 6, 10, and 14. 505, 2, 6, 10, and 14. I will see you in class.